This time we will speak about binomial coefficients, which is a very important topic for us because binomial coefficients can be found not only by Pascal triangle, like it is said here, but we can expand it for any n. And imagine that this n can be very large. So if it is 100 or 1000 or something, then Pascal triangle is not the case because it's impossible to draw this in a short period of time. So that's why for larger n, we don't have to use the Pascal triangle, but we need to have a more efficient method. And this method is by calculation of binomial coefficients. So this is what is important. And here we need to understand one thing. Pay attention to this part. It is really important when you have the calculator. You need to try yourself like this. So just find this key. It can be also sometimes on the shift button. In my channel, I have also how to find the short video, how to compute combinations with this button. You can find it in my video, in my channel, but here, this is how you can calculate. So just take 5, this is above number, this is like n, and this is just n, and take 2, this is the odd number of the coefficient, and you will receive the answer. But let's say what is happening here. So let's just try to see the example. Here you can see a very simple binomial and 1 plus x to the power of 5, and you can see all the coefficients here. If you have Pascal triangle, you will have all those coefficients. But now we need to figure out how to find those coefficients using the calculator and using the so-called combinations. So we can write to use combinations. And the combinations you will also use in probability and statistics a lot of many times. But here we have to find those. So try to use the calculator and just take your calculator and calculate this. Here, this one will be just 1. This shall be 5. This shall be 10. This shall be 5. This shall be 1. No, here should be 10 as well, sorry. Yeah, so here should be 10 as well. And here should be 5, and here shall be 1. And what is interesting that when you compute these things, we need to do the following statements. So here you need to know what kind of coefficient is there, what kind of order of this coefficient is there. You can see the coefficient of x squared in the expansion of is. You need to know where is x squared. And if you pay attention to the above expression, you can see that if we start 1 plus x to the power, then the first term has no x, the second term has x to the power of 1, and the third term it has x to the power of 2. And so on we go until we reach the maximum power. This is in the case when you have just number plus x to the power of. And if you want to find the coefficient of x squared in the expansion, you need to find basically this is that. The coefficient will be 10. And here, if you want to find 10, so there is a possibility that you have here or here. And see, this is the order of your term. So here we go, starting from the first 0th term, the first, the second, the third, the fourth, and the fifth. So altogether there are 6 terms. You can count also without 0 by 1, 2, 3, 4, 5, 6 as well. And if you want to find that, we need to know what is the coefficient. Here, if you want to have coefficient of xr in this one, so what you need to do here, basically, you have to take here 2. You can see here, sorry, you need to take here 2. Here, if you want to find that, you need to take here n, and here you need to place r. And if you want to find the coefficient of the fourth term of the expansion, what does it mean? So fourth term of the expansion. And you can see this is zero term, the first, the second, the third, the fifth, and the fourth. So the fourth and the fifth. So if you want to find the coefficient of the fourth term, so we need to figure out what is that. And if you want to find the coefficient of the r plus 1 term, so we need to know here. And here it is, we can try later, we can see that. But what is important that here you have, if n is an integer positive number, then you can always decompose this as the following. So here, those are the combinations, and you know also how to find it using the calculator. So here we can therefore write this expansion of using the binomial coefficients, and binomial coefficients you can find always like this, and you know how to calculate them now using the calculator. And here we can use this theorem as well for any kind of things. Like you see, if you have a plus b, and here you have the same, like a to the power of n taken out, and here you have 1 plus b over n to the power of n, and assume that a is not 0 here. What is interesting, that here, if you have a plus b, you can always create the following. You can get that these are the coefficients. This, and this, and that. And you can find them easily. And look, here you have to find the ascending powers in the first four terms of the expansion. So the first four terms, it is 0, 1, 2, and 3. So here you start, and you just find it. And if you want to find the first four terms here, it is the same, like you do the coefficient, and here you have this one, the first power to the power of the largest. Then you have the second term will be, you just take the first term here in the brackets and take it to the power which is smaller by 1, but you take the second term and multiply it by everything, and you take it to the power of 1, and so on. So it depends. Here the number, this number shows you to which power you have to take the second term, and this power is taken like the maximum minus this. So you can see, if we have to work on this, we have to know that how to compute without calculator. If you have 5, 0 and 5, 5 from the Pascal triangle, you always know that these are ones, so you can just take them and take it for granted. So n over 0 is always 1, and here n combination is always 1. So this is important to understand. And if you want to write it like that, so here you can see that we write it as the following, always like 5 and here 1. Here, if we have 5 and 2, we just take 2 of the x of this, like a 5 times 4, and we decrease 1 by 1. And here we have like 2, and we decrease it by 1. And here you have 3, so we will have summand like that. You can see that it shows you how many different numbers you will have. So if you want to find, for example, 7 over 3, so 7, 3 combination, then it is like 3 times you have. So it will be 7 times 6 times 5, and 3 times you took. And here you have 3 times 2 times 1. And here you can get, so this one will disappear. And here you have 35. So this is 35. This is how you calculate it. And in general, if you have such formula, so you need to understand it one more time. If you have n combination r, then you have to count it like this. You take r times the product, and each time when you multiply by the next term, you decrease this term by 1. So if you have r terms, you have first term is n, then next is n minus 1, the next is n minus 2, and in total you have them, amount of them is equal to r. And here you just take this r and just decrease it by until you get 1, and that's all. So if you want to have it without calculator, how to do that? You can see, just do it like that. And you can cancel some of the terms and get 70. It's quite easy. So just have a look. For example, here you can cancel this and this, so you'll have here only 2. Here you can cancel 2 and 2, and then you will have 3 and 3. I can cancel with this, so it's less 2, and then 35 times 2 is 70. So it's quite easy. And here, if you have n and 4, you know that basically you have only 4 terms multiplied, and then you start with n, then you decrease n by 1, then you decrease n by 2 and by 3, and that is all because you have only 4 terms. And here below you just have 4, 3, 2, 1, and that is done. So this is how you do that. If you want to find expansion of that thing, when you just expand some of the more complicated stuff, you see here we have a fraction and so on. And it is expanded in the ascending powers of x. So if you want to do it in the ascending powers, so you can see the coefficient of x squared is 4. So how do you do that? So find that n is the positive integer, find the value of n. So here is like example what you have to do. When you have this expanded in ascending powers of x, the coefficient of x squared is 4. Yeah, so it means that you have only x squared in this term. And given that n is the positive integer, find the value of n. So you need to find the value of this n, which is positive integer. Then you know that the term in x2 you need to find, so it will be like this, the combination. And of course, if you take this x2, then x is here in the second term, so this that shall be taken in the power of 2. So if you have to take it in the power of 2, here is 1, so you don't take it. And then you have this in the power of 2, and this is 2. So you can see here, just this one you can easily calculate, and this one you can easily take this one. And then you have the following. So just simplify and get the value. And now you have the equation because it is equal to 4. So if you have the coefficient equals 4, then this part, only this part, will be equal 4. This is here. And then you can have the quadratic equation, like 18 times 4 is 72. And you have 2 roots, but this root doesn't go because it's negative, and then you have one root is positive. These expressions you will have an exam, so please just concentrate on them as well. And another example you can see here, what we have is you have like when 2 plus kx to the power of 8 is expanded, the coefficient of x to the power of 5 is 2 times the coefficient of x to the power of 4. So here you need to find two coefficients and make them like together, like showing that one is 2 times larger than another one. And you know that k is larger than 0. So it's also quite easy. You can see here if you have the coefficient of x5, you know that here you just expand the number and the x. So the power of 5 will be only in the fifth term. So here you just put it there. And here you have then if you have the power of 5 here, but it's expanded to the total power is 8. So here the power will be 3. And the coefficient you know. So this one you know, and this one you know because you know the powers. And just if you open that, you can see that this one, and this is the coefficient before x to the power of 5. Now you do the same with x to the power of 4. If you want to find the coefficient before x to the power of 4, then you take the combination 8, 4, because 8 is the total power and 4 is the power of x. Here you just take 4. Why you take here 4? Because it is the difference, because you have total power of 8 and then you have here 4, so this is basically 4. In this case you have 8 minus 5, and that's why you have 3. So this why you have 3 here. This is important. And what is next? You just according to the exercise know that k is larger than 0, and you know that the coefficient before x2 is 2 times the coefficient of x to the power of 4. So it means that x to the power of 5 coefficient is 2 times larger than the coefficient of x to the power of 4. Then you take this coefficient and say that it's larger than this. And then you have the equation. you can open that like that. So here you have k minus 5, k to the power of 4. K can be 0 and k can be 5. But of course, 0 doesn't go because it should be integer and positive integer. So case 5 is the only solution. And if you go for the next one, you can see here, if you want to obtain the first three terms in the expansion, and this is also very often used in the exams. So here you can have also a very interesting situation. You have expansion of that. You know how to expand this guy. We already spoken about this. And you know that this is just a bracket which is multiplied. So you need to know that altogether this one is also influences the total power of coefficients. And obtain the first three terms. So you need to obtain the first three terms. So what you need to do, you need to leave this bracket as it is, but this one you need to expand. And if you expand the first three terms, here you can see how you expand them. So the 0, the first, and the second term, because these are the three terms. And if you take the 0 term, so it means that 1 shall be into the power of 9, and 2 to the power 2x shall be to the power of 0 here. So they just disappear, and that's why you have just 9, 0. If you go for the second term, you can see that here you take 1 already. So it means that 1 will be to the power of 8, and 2x will be to the power of 1. And then you go forward, you have 9 over 2, 9, 2 combination, and then you have 2x to the power of 2. And this one, you just can ignore it, because 1 to any power, finite power, is equal to 1. And then you have this one, but you have also this part. And what you have here, you need to multiply them all for these three terms. And then you can calculate those three terms, of course. You see you're calculating. And then you have here the other multiplier. So you just multiply that and you just put all this together. Like, here you have 2, here you have 36, and here you have, it's like very fastly calculated, but you can see that here we have minus 6 as well here. So they just unite those things and these things in this guy. So this is how you do that. And here you have this and that. So you just put it together. And that basically is. And you can see here you have to trick up to x squared. You don't need to take x cubed. So this is what you have. And now, if you have this, the first three terms of expansion is the following, because these are just, if you have ascending expansion, so this is the first three terms, as this is without x, this is with 1x, this is with squared, so this is that. And then use your answer to part A to estimate the value of that. So we need to estimate this value. So what we need to do is we need to estimate that value for that. You can see this is 1.99 times 102.9. So how to do that? You can see that here, if you have 199 and here 102, so what you can do, you can see 199 is equal to minus 001. And 1.02 is equal to 1 plus 002. And look why I'm writing like this, because if you want to write it like that, you can see that 1.99 times 1.02 to the power of 9, it is basically 2 minus 0.01 multiplied by 1 plus 0.02 to the power of 9. And this expression is resembling that one. Absolutely. And this is what we have to learn why we use it, because it's for precision making. And this is like the first things about the series. And I like this method in this book because they do give you a lot of understanding afterwards why you use those things. And here you can see that you do that. When you do this, you can have this x. You can see in this problem, you have basically this problem is like 2 minus x, 2 minus x, and here you have 1 plus 2x to the power of 9. And you can see that here you can use x equals 001 because it's exactly like that. And if you have it, you can see this is the first three terms of that. And you just can insert here instead of x, just 001 and 001. And you receive approximate answer. And this is really cool. I like this. So this is how you can do the approximations. And you have to watch it once more time to understand if you don't understand it as well, because this is a very big important thing that you need to know. This is just the salt of this part, as you can use it later in different other terms, even in physics. And the alternative things like of doing the calculations for these formulas, uh, it's like you can try to use the factorial notation. You can see that if you write this one as a factorial notation, then you can get like in general factorial of n is multiplying all the numbers from 1 until n. And then this formula becomes the following. So if you want to use the factorial notation, it is also nice. And if you want to multiply it, just to find out different things like 8, 4, combination 9, 3, then you can use the factorial method and do that whatever you want. But you need to understand the factorial as well. What is factorial? And factorial is just if you take factorial 5, this is 1 times 2 times 3. So here times 2 times 2 times 3 times 4 times 5. So this is how you find the factorial. And here you can easily find it and so on. But for example, find the term independent of x in the expansion of that. So here you need to understand which term becomes independent on x. But here you can see that we have x here and x here. And if you want to find a term which is independent on x, we need to firstly solve the problem when it's just cancelled. And you can see that the terms, the x terms cancel each other when the power of x is double the power of this one. Do you understand that? It means that if you have to expand this, if you have to expand it, you know that here you will have 9 over, here you have 9 over some kind of number k, and here you have x to the power of 9 minus k, and here you multiply it by 5 over x squared, sorry, it is x squared to the power of k. And if you have to deal with this, and we need to understand that this amount multiplied by these shall negotiate. So it means like 9 minus k shall be equal to 2k. If they are the same, then you can just figure out. And you can see that if you have this, then you can see that 9 equals to 3k and k equals 3. And here you can see these are the powers like that, 6 and 3. But the corresponding binomial is this one. So here you have like 9 and 3 or so. So here you have x to the, you can later find it, and then you can see that this is, if you put here 3, then it will be x to the power of 6. Here will be x to the power of 6 below, so you will cancel it. But what you will have left, you can see here you will have 84, then x to the power of 6 is okay, and here you will have 5 to the power of 3, 125 over 6. And then if you just cancel those x's, then you need to multiply 84 times 125, and you will receive the answer. So please pay attention to that as well. And here we have the tasks, so I will solve them in separate videos. Some of them I'll solve, and you will see how to do that. Thank you very much.